So the interest rate will differ with if they borrow the amount about 500 million, no, $500,000 with the same fixed cost at $1,000. So that's why they also control for the amount decided here. Okay. So first, the first main part of the result is the baseline discrimination that they transform whether the mandatory group will have the higher interest rate. So the result show that the minority borrowers Latin and black pay significantly higher interest rate than risk equivalent non-minority borrowers. Estimate interest rate differential in the basic bond for the dataset in GSE purchase loans, the interest rate difference is about 4.7 basic point, and for HHA purchase loan, that amount that figure about 4.9 basic point, and for the refinance loans, that figure about 1.5 to 1.6 basic point. This method estimate identify within credit stock and loan to value risk buckets. So that's control for the entire risk effect. And we can see although this kind of low figure, small figure, I mean basic point, it are 4.7 basic point. That means the difference in interest rate just about 0.047%. But these gap are economical, meaningful, representing a sizable share of lending profits, and they calculate that if the difference in interest rate about, for example, 2 basic points, it corresponds to about 20% of total loan profits. So that is a sizable share of the lending profit. Okay, so next is about fintech and geography. They want to research whether if apply fintech, I mean apply algorithm in technology to check or scan for the profile, can avoid the discrimination in issued loan, but the result not that good. For GSE loans, mandatory interest rate caps are about similar across fintech and non-fintech lender. And for FHA loans, fintech lender show smaller but still positive. This positive, especially for purchase mortgage. So fintech lending does not automatically eliminate discriminatory pricing. About geographical pattern, mandatory pricing are larger in high mandatory share sensor check and port average interest rate, and mandatory non-mandatory differential increase with local mandatory share. For this preparation, they also control for the area of the borrower. For example, they control it by they calculate the number of black and Latin people in this area, and group the area by about 30,000 to 40,000, I mean 30,000 to 40,000 persons in that is a population of the area, big area, and they calculate the rate of the black and the Latins of the area, and construct the sensor check here by that. Is the question answered convincingly? We evaluate that identification is highly convincing because the data is quite large, scale with stable results, and it also has the clear policy relevance because according to the fair pricing of the US, government forced that the interest rate will reflect should be reflect the credit score, not all the characteristic of the borrower. Okay. Yeah, that's also the last part of our presentation, and the last is the reference body table.
So very good. Thank you so much for your presentation. And so now I'd like to open room for discussion among participants. Do you have any questions so far?
I think this paper is quite interesting because actually at the first time I read the regression model, I don't understand.
Okay.
Yeah, I don't understand, so I need to pay more time to check each element of the model represent what.
Okay. So probably maybe you could show us the regression,
Yeah.
right? And then we'll do discussion with you. Okay. So let's say when you first had looked at the regression, what was your, I think, concern, or why are you so scared about that? So is this way too much, or you are not sure how to measure the, let's say, the coefficients of, I think here we have mu, right?
Yeah.
And also alpha.
Yeah. Because they use a lot of variable to control for physics effect.
Yes.
Yeah.
Okay.
And they control for the risk score.
Mhm.
They control for the time and control for the individual. I mean the borrower.
Yes.
And also with time, and they also control for the amount of the rent. And I think this is really interesting if I mean the reader don't work in bank and don't know the rule of or the process of issuing banks. So that's why when I read about that, I thought it's really interesting because it's kind of a new language for me. Yeah.
Okay. Very nice. And I just want to have a quick question regarding the, let's say, first, we have to distinguish about the statistical coefficients, right? And its economic magnitude, right? You mentioned briefly that although we observe quite relative value for the coefficients, but the economic meanings of those numbers are quite large.
Yes.
Yes. Could you please a little bit elaborate a bit more about this one? So how should we know, or how do we know if the effect is indeed economically meaningful in real life, or in wisdom, let's say, real data like this, right? We do not rely on just regression.
You mean how they calculate the share of lender profit corresponding to the difference in interest rate?
Yes.
Yeah.
Okay.
Actually, I don't know, so I didn't know. So I thought about that.
Yes.
But when I thought about that,
Mhm.
I also don't understand.
Okay.
So I just know that there are so the US government, they have a rule that
Yes.
maybe maximum share of profit that they I don't understand, but
Okay.
there are some formula
Mhm.
based on the US rule.
Yes.
Yeah, and based on some financial rules, and they use those formula to calculate the real share of lender profits corresponding to the difference in interest rate. Yeah.
Yes. Okay, perfect. No worries. I'll go on stage and we will have a live discussion over there with you. So first of all, let's say when we have any marker here. So from your perspective, how much, or let's say, what is the key selling point of this paper?
Key selling point of the data. Yes, because almost the previous literature, they focus on the time global 2008.
Yes.
Yeah, and the data they use, they cannot isolate, I cannot control for the risk factor.
Okay.
So in this paper, the author tried to combine four large data sets,
Okay.
to get the full information as much as possible.
Yes.
And luckily that they have for example H3E and F, for H3E's data, they have the credit score and LTV. LTV is loan to value.
Yes.
Yes, for them to construct a variable to control for the risk of borrower. Yes, and actually they build the kind of risk that have 64 all.
Yes. Okay. So like the cells, right?
Yeah.
Okay. Good.
They
So,
do something of their own.
okay.
Yeah,
Is
represents.
there? I think they included the grid in the paper, right?
Yes.
So probably, could you please show us? We'll just have a look, and then.
This paper, the include appendix too. Yeah.
Okay.
So but they also highlight
Mhm. So the grid here is, let's say it is reflecting the different level of interest rate or.
different level of risk, credit score, credit score. Yeah.
Okay. Or we call it like the credit worthiness of somebody, right? Okay. This one is the summary statistics, right?
Yeah.
Okay. So let me have a look. So what is the above and the below?
Above is
Panel.
GSE runs data.
Okay.
Yeah. We
Okay. And do they have like have they split the sample into two? Basically, the one is for the treatment. In this case, that is our Latins and black, right?
Yes.
Okay. So we have here Latin and black. And the next one, we call it like the control group. What is that?
All the
Yes, they have like they identify as
white
Y.
Asians. Yeah.
Okay. Okay. Yes. Very good. So this is our treated group, right? And here is our control group. Yeah, because this one is we call it like the fixed effect model, right? And is so previously we covered what? What is the method, the powerful method that help us disentangle or rule out the endogeneity in all of the three problems we had before? You remember?
Yeah, triplet and control.
Yeah, the instrument, right? The instrumental variable. So we have instrument. So this one is the ID, right? And what is the next method that we are trying to make use of the exogeneity of the shock? affecting two groups. Yeah, so it's a difference, indifference, right?
Yes.
So we call it like VID, right? And recall that back then, I also told you that if we could make use of the power of panel data, right? Then we could try to then we could use the fixed effect and random effect.
Yeah.
So random effect. So FE or and then RE. Right. We should focus on this one first. And what else should we pay attention? And so I will come to this one later. But what is the motivation or why do you think we should use or is appropriate to use fixed effect in the model? So yeah, because we do not have the IV, right? We also don't have like any shock to solve with the DD. But what is the very core, very underlying assumption of the fixed effect model?
You can remove those like time
Very good. So let's say we are dealing with time invariant, right? This is the keyword for this one. So we focus on time invariant characteristic, right?
Also on the characteristic, like entity.
Yes, very good. So actually here time variant, that exactly sure, and later I will explain to you different level or different let's say kinds of fixing types in the model that you showed before, right? So this one we care about time invariant. So you remember yesterday when we talked about, let's say, the omitted variable mass, right? Let's say I will just write something here. We have a very basic stuff like, how to say, wage, right?
Yeah.
What else? Alpha plus beta.
Education.
Yes, exactly. So I hope that now you are, let's say, familiar at this very, let's say, classical example, right? You reinforce into your brain. So here, this is education, right? And we are not quite sure if there is something going on here, right?
Yes.
So if we are missing something like, how to say, exactly, so or this is, this we use the case of like the ability,
Yeah.
right?
conversion.
Yes.
Should not vary over time.
Exactly. So ability plus epsilon, right? And so we could use the IV to solve for this one if we could find any instrument for that. But here, thanks to the very fact that we have time invariant, by this we assume that people with high ability, they were born with such, let's say, high capacity to process number quickly, to do, or let's say, to learn something very quickly, learning topics way faster than we call it maybe the normal person or with relatively lower level of ability, right? So and if we assume that if time, let's say ability is time invariant, right? Then I think one of the next way that we could have a look on that is trying to plot the values, right? For example, for this case, or I think it is quite interchangeable, we use that. If you plot some data, right? You see that one group, probably he is the log wage of someone in this low area, right? And here, maybe here, right? Something like this. So, if we just run one OLS line here, we probably ignore the dynamics, right? The difference between the two groups. If we have just this regression line, this is OLS, we just find the average value, right, for the average person. But now we see that this one, it looks like this is one cluster, right? And here this one is another cluster. And it's always higher over time, and hence, let's say, and because, for example, people are performing well, they tend to keep that image level through time, right? So when we have a look at this, we see that also, so probably there is some time invariance difference between the two groups. And if it does change over time, then we could not solve with this big effect, right? Because probably I want to argue that maybe before high school, I was so lazy, although I'm smart, but I'm so lazy. And so my performance is relatively, let's say, bad, right? And maybe before, let's say, I graduate bachelor degree, I don't focus on study. But right after that, right after I graduated and I joined the labor market, my true ability really show up. Then it's really time sensitive, right? And that's not the case. But here we focus on capturing the ability, and therefore, if we do have certain, let's say, confidence that the difference does not change over time, right? This. So maybe the average here is always much higher, and it doesn't change over time. What we could do is to run a regression to capture for that. And here maybe we just have one, let's say, dummy variable. Over there, you see that here we have the dummy variable to really capture that unchanged effect over time for different groups. Here, how many groups do we have? We have black, right? We have Latins and black. And what else? We have the white. So probably now if we have one dummy variable that capture, or one custom variable that capture the effect for the, let's say for the black one, right, or the white one, that's okay. The other coefficient or the intercept will capture the effect for other groups, right? And actually, as you also notice that we have this model, but indeed, in the end, what do we care about? We care about which coefficient here?
Alpha.
Exactly. So this one, it has the power to help us, let's say, capture the time invariant. But in the end, what we care about is the true, right? The true magnitude and the true coefficient of alpha, right? Okay. Good. And let's say here we have lender times year month. Do you have any idea why do we have to use this one?
Because within a person, they also have different like different behavior. Yeah, different behavior across time. That's why they use interaction variable here to capture the exact effect.
Okay. That's very good. So let's say, although it's time invariant, but probably each group of lenders, right, has different level of how to say the interest rate they're lending to people. Or to be more specific, let's think about the case of interest rate in Vietnam. Have you heard about the Big Four bank? So the Vietcombank, the Viettin, and BIDV, and the other one I don't know, I don't remember exactly. But let's say here, let's say we have Big Four banks, right? And non-Big Four banks, correct? And do you have any idea about the difference between these two groups related to just interest rate? So isn't it the star effect that Big Four banks usually they are backed by the government,
Yeah.
and they offer a much lower interest rate, correct? So lower non-big four bank is higher relatively, right? Relatively,
to
this non-big four banks, right? And is this, let's say, constant over time? It looks like they are always higher, right? And to some extent, we could capture that effect, but we also have another dimension. Let's say time, right? So we have the time dimension, something like that. So maybe this is a year, right? This one is the lambda. Okay? So here we may have, if you want, you could split them into 2008, before 2008 or after 2008. But if you want, you could use something like maybe 2024, 25, and 26, correct? And just a few weeks ago, we heard that, what happens? So here, we observe let's say an increase in, let's say lending and even borrowing rates, right?
yeah.
So you put money into the market, you earn higher interest, but at the same time, if you operate a business, right, you have to pay like high interest rate, or for those who, in this case, they borrow money from the bank to, let's say, finance their acquisition of a house. And all of a sudden, previously we have the cheap money period, right, in 24 and 25, but all of a sudden we see an increase, right, in interest rate. And we do not know whether this is systematic or not, but let's say, imagine in year 2026, all of the banks, or there are some factors or some underlying procedures that drive up, right, the interest rate for all the banks here. And actually, we do not care about whether it is like the exact number of that, but maybe we could see an average increase in all the banks, and hopefully it will include this fixed effect. We could capture like the average increase in all the banks in year 2026, correct? So we have two types probably here. If we translate this one, so we have here the mood of lender, right? And here, probably here the mood of year, right? So here, if we have two types of lenders, we always keep one for the intercepts, right? Because it capture one group, and the real lender for, maybe I say that the fixed effect for big four banks, let's say, will be captured by this one. And here we have also a list of years. One will be used for the coefficient, and the others will capture the time invariance over the, or let's say we just assume that for this specific year, there's something going on and that affects the entire, let's say, sample, right? And we could push it a bit further by introducing this interaction term, right? So here. And how about lender and years, right? And year. Right. So we call it here. So one could always argue that in year 2026, if or there are factors that drive up the effect of the average bank in our sample. However, one could always predict that probably the effect for maybe Vietcom Bank is different than the one of maybe Sacom Bank, right? Or here, maybe for different years, the effect for the Black and Latino will be different for, let's say, for the white and other groups. And by doing that, we allow, let's say, so we have different groups, right? Have different patterns, right? So maybe if I assume something here that right. So here maybe 22 and then 21, right? So first, assuming that the one for the maybe group that is the black and white, right? Let's say, for example, they are always higher. So we have something like this. And if we just map it with this case, we have big 4 and non-big 4. So let's assume that non-big 4 is always lower than the, non-big 4 is always higher than big 4, right? And let's say here, if big 4, then we have something like this, right? Then we assume that for different types of bank, at different years, we have different fixed effect, right? And let's say how many letters do we have here in this example, in this paper? No worries, maybe we'll just use this one. That's okay. So let's say, for example, if we have two groups here, right? Two groups here, like the big 4 and non big 4, or the black and Latino and white. And let's say if here we have 3, right? Then can you guess how many fixed effects will be captured with our interaction term there?
If if the data set have over about 1 million letter, and they will have
Yes.
1 million.
So let's say 1 million letters, right?
Yeah.
Or let's say, okay, so
It's not. It's not exactly the. The number, but
Yes.
because they have the total over 5 million, right?
yes,
Yeah.
okay. Then let's say, so here we have in total 2 groups and 3 years. Let's say we simplify the example. So we expect to have in total 6 fixed effects,
Yeah.
right?
Yeah, and the data sets, the parent have 6 years.
Yeah, exactly. So we have 6 years, right? Times the number of letters. So in theory, we predict to have that exactly like the multiplication of 2 numbers as the numbers of let's say fixed effects we have here. So are you okay so far? So we have different level of letters and different over year, and we try to capture it for every year for them to make sure that those will have us ruling out the difference in level for them, right? And what is left, or let's say, so we have here, what is the, here we have the interest rate, right? Interest rate. What else? Alpha plus beta, let's say Latino times flex, right? Or we call it like the dummy, right? The indicator, if someone 0.1, so black or Latino, correct? And then a set of fixed effect, something like that, right? Just draw it. Plus epsilon, right? And here it's not only one, but indeed how many groups do we have and how many interactions do we have when we assume that those are quite different for different groups and different types. It will be captured by a set of fixed effect here, right? I will write by a set of fixed effect. But only or in the end, what we care about is after we capture those time invariant for different, let's say, groups, this is still our variable integers, right? And I think they have shown you the difference before controlling for our fixed effect and after, right? So we see a difference in beta value. Basically, that's it. And what else should we care about? Or do you think if we control for a list of fixed effects like this, what might be the consequence?
You lose observation.
Exactly. So you lose observation, and in econometric terms, you remember there's something that we use? Something with a degree.
Yeah, degree freedom.
Yes, okay. Degree of freedom, right? So if you include one variable into your regression, you will lose one degree of freedom. And imagining if you have 1 million lenders,
I think I have a mistake because this the amount of lines represent for maybe
the
the
low levels,
now
right?
the borrower.
Okay,
But like we talk about the lender.
yeah, exactly.
Lender is the bank.
Yeah, so it's the number should be smaller,
Yeah,
right? But
yeah,
still we have
much smaller.
different lenders,
Yeah.
right? Exactly. But yes, and in, let's say, general, so if we have different groups and we try to, let's say, interact them, then we will lose the exact numbers of degree of freedom. And therefore, as usually if you want to control for, let's say, fixed effect, we always encourage you to include, or at least to tell us why do you want to do that, right? What is the, let's say, how to say, the motivation behind. For example, if, let's say, we know that for some banks in some year or in some state, they tend to have higher level of loans for two groups that are different, right? Maybe in California or in Texas, the difference is quite huge. But in smaller states, the difference is much smaller, right? And therefore, we know that different states and different years may have different, let's say, characteristics, right? But of course, what is core assumption here is they will change over time. But if they, here, when we interact, we allow them to change a bit, but to some extent it's still very strict, right? There is no dynamic, let's say, motivation or, let's say, the generating process for this variable is not fluctuating that much. And if that's the case, and if we have a set of fixed effects that are relatively small, then I think it's okay. If, let's say, for example, we have a list of maybe 20 or let's say 5,000 of fixed effects, but it's still a lot already. But if we have maybe 56 million of loans, so you have different level in total, let's say 6,000 rows, right? And you lose only a relatively small amount of freedoms, then that's okay. But if you have a sample of only 2,000 observations, and you have already maybe 200 fixed effects, then you will face, let's say, the biggest problem here, because now the results are not reliable, let's say, reliable anymore, right? You control for too much, you include too much, and why, let's say, in your opinion, why do we include a lot of fixed effect? And that will lead to some, how to say, some inconsistency in measuring it. You have some idea behind? We talk about variation.
Because if you change, if your degree of freedom
simplistic and it leads to wrong conclusion, right? And here, for example, this one, those are the data that we have, right? So maybe here, let's call this one is the black or Latino, right? And this one is the white and others, right? So we do see that here there are two structural differences between two groups, right? We try to capture that with the fixed effect, and that might be probable, might be the case that when we control for too many fixed effects, we do not see variation anymore, right? Because all of the variation of the observation will be captured by those fixed effects already. So now maybe the line is not this steep, but it will be flatter, right? And that means your coefficient, your slope of your regression line will be now flatter and it will become insignificant, right? Therefore, just one word that is always recommended to include the fixed effect if you do have a strong motivation or strong belief that the groups are indeed different and the difference does not change over time, but do not control for, like let's say, do not control too much, otherwise you will see a problem with that, right?
Can I ask a question?
Yeah, sure. Please go ahead.
I'm not sure whether you want to have a separate session to cover the handle data of the fixed effect, but my quick question is just like, when to use the first difference or when to use the mean?
I see. In fact, if you have a, let's say, if you have like balance balance, right? The two effects are indeed the same, right? Why is it? Because now, what is the first difference? You take T0 minus T1, right? And we assume that the time invariant characteristic do not change over time, and when you subtract T, let's say T minus 1 from T, they will cancel out, right? So that's the difference. And here, if you use the fixed effect, then we also capture it by this one, and if you just subtract them, they also disappear. But let's say the reasons or the choice to use them, or let's say you mentioned about the mean, right? You subtract your variables from what? From the average, the mean, right? And also it will, all of the time invariant characteristics will also disappear, right? All in all, if you have a balanced panel, then the two, we also have two groups, then the choice of methods might not be that sensitive. It's quite, let's say, consistent, right? Because you just rule out this constant effect. Yes. And if you want later in the lectures, we will have a small exercise to prove that. Why are they equivalent? Yeah, but of course, if we try to include a lot of, let's say, fixed effects here, you will lose lots of like degree of freedom, right? But over there, when you, let's say, subtract or we find a difference, then it, how to say, if we do not care about like the level increase or decrease, but then you have the delta, right, in it, and you care about like the delta increase or delta decrease over here. It affects your interpretation of the results that we have. But in fact, if we do anything like to approach properly, then the beta coefficient should remain the same or should be comparable between the two groups. Yes. Okay. Thank you. So is there any other questions? Okay. So very good. This is, yes, we cover fixed effect here. And in the next paper, which method are we going to cover in your paper? This for LS, is there any like difference or not?
It's not any different.
Okay. Then I'll just leave it there, and later we will let's see what's coming next. And I think so far we cover almost like the key approaches, right, that we learned in the course. But now it's more or less we talk about how authors are trying to this entangled effect, or we talk about the identification strategy, right? Identification strategy. This is what we should pay attention whenever you read a paper, right? Probably for OLS, it's quite simple, but they have some channel or some methods to extract the true effect. And so I'm looking forward to your next presentation. And thank you so much for your presentation here. Okay. Okay, so I suggest we have 10-minute break before we come back to the next presentation. Có cần phải vẽ thì nó đẹp bản không em hả Linh?
Dạ, để em
Chắc bản trên bản dưới đi ha, chắc là đủ rồi đúng không?
dạ, thầy thấy